reaction. And I gave you one on the test. We're asking for delta G of the reaction. It is exactly the same process. But for this one, what type of numbers do you use from that table? As numbers. And for this one, what type of numbers do you use from the table? G numbers. I'm not going to do a problem, okay? We're all adults here. Most of us anyway. Some of you are not adults yet, right? Some of you are still growing up. So, calculate delta G under standard conditions Okay, so how do we do this problem?
Use delta G equals delta H times T delta S.
Okay, I'm giving you delta H and I'm giving you delta S. So what we are going to do is use this equation. Delta G under standard conditions for a reaction or for anything. Okay, let's put this in general.
I'm just curious, you want it in kilojoules or joules?
You have to do it yourself, man. After all of this time, you still have not learned that. Delta H, plus or minus? Huh? Minus T,
Delta S.
delta S. Okay? That's the equation we are going to use. And we have delta H, do we not? And we have delta S. So how simple is this problem? In the complication chart, this will be the simplest possible. Just plug in the stuff, right? 3 points on the test. So delta G is equal to delta H, which is minus 92.38 kilojoules. Minus T, and T is the temperature. What's the temperature here? 298 Kelvin. Now, I have to have this in Kelvin, do I not?
Yep.
This has to be in Kelvin so it cancels out. Okay, it can't be in degrees Celsius. It may give it to you in degrees Celsius on the test. Multiplied by delta S. 198 G per Kelvin. Now, we're going to have a problem here, yes or no? K, the K cancels with the K. We're going to have a problem?
Yeah, I want to see two.
Yeah, this is the problem that he was asking about. This is kilojoules, and you cannot add or subtract joules from that, can you? If it's kilojoules here, what do you have to have here? Kilojoules. Now, I can change either unit, but is delta G given in kilojoules or joules most of the time?
Kilojoules.
Delta G is given in kilojoules, so we got to change this one to kilojoules. I'm going to write joules on the bottom, kilojoules on the top. 1 kilojoule has 10 to the third joules, okay? The answer to this complicated problem is minus 33.3 kilojoules. Good morning. Yes? How's that?
Good.
I mean, I don't see how this could be simpler. Okay? So I'm going to say, for the same problem above, calculate delta G at 500 degrees Celsius. It's consistently late. Where's Miss Vega? Anybody know? She's taking care of the chicken? Oh, no, not you. The chicken girl. So how do we do the problem?
Change the temperature to Kelvin and do the same thing.
Change the temperature to Kelvin. Is that what you would do?
Yeah.
Okay. And this up here means what?
Standard conditions.
Standard conditions, which is 298. Can I use these numbers to calculate? I shouldn't have put this here, okay? Because we're not calculating it. That's not under standard conditions anymore. I'm going to erase that on your paper. Now the equation is the same. What you have to notice is that these numbers are calculated at what temperature?
298.
At 298. So, do the numbers change with temperature, yes or no? Do these numbers change with temperature?
Yes.
Yes, of course. This one does not change by much with temperature, but this one changes with temperature, okay? But it changes by little. So what we are going to do is, when I ask you to calculate delta G at another temperature that is not 198, 298, what you get is an approximation. Write it down. We are going to use numbers to calculate this delta G that are under standard conditions, are 298. We're going to use it for a different temperature, and we're going to get an approximation. So is this going to be the exact number? No. Should it be close to it? Yes, of course, it should be close to it. Now, whether the number goes up or down depends on this, yes? Depends on the sign of these things. So, but let's do it just the same way. Delta G is equal to delta H, so I'm just going to write it, okay? Minus 92.38 kilojoules minus the temperature. Temperature here is 500. How much is it?
773.
773 Kelvin. Okay? So at 773 Kelvin, what I am going to multiply that by 198 joules per Kelvin. And the same thing is going to happen. I got to change it to
Kilojoules.
kilojoules. So joules goes on the bottom, kilojoules on the top. How much is this?
0.198 negative.
Kelvin cancels. How much?
0.198 Kelvin. Kilojoules, sorry. With a negative.
What?
Negative 0.198.
Huh?
Negative 0.198.
0.198.
What do you mean? You're taking that number and dividing it by 1,000.
Oh, you trying to get the whole answer?
Yeah, the whole answer.
Oh, okay.
60.7.
Is that the right temperature for toast?
What? It's 500 Celsius. You add 273. No, 298 is room temperature, 25. 25 is 298. So what is it? You said 61?
No.
I got
Well,
60.8.
Yeah, 61, right? 61 is good. 61. What happened? Tell me. What happened from here to here? It went up.
Pretty much double.
Tell me, as far as the sign is concerned, this is what? Spontaneous or non-spontaneous? I can tell it's negative. Spontaneous or non-spontaneous?
Spontaneous.
Yeah, you guys have not studied it. That's okay. Negative means spontaneous, okay? Negative is a good thing for delta G. So negative means spontaneous. Positive means non-spontaneous. And remember how we were doing this plus and this minus thing? You remember? So here's a minus. Yes? Here's a minus. Let's say this is delta G. Delta H minus T. Delta S, yes? Here's a minus for this. Minus and another minus. So this is going to give you a positive. Now when is this going to be spontaneous? I want this thing to be negative. When this number is small. When this number is small, that number will be bigger and it will be negative, yes? So when is this number going to be small or spontaneous? When? Low temperatures, yes? At low temperatures, this number is going to be small. And this number will be bigger, so it will be negative. And what happens as I start increasing the temperature? This number starts increasing, yes? And it will eventually, if the temperature is very high, it will go from spontaneous to non-spontaneous, which is what happened here. This is non-spontaneous, because at high temperatures, this will win. Okay? You have to know that. That's okay if you don't know it yet. Okay. Questions about this, guys? All of the questions I have now on the board are on the test.
How would it be worded on the test? Those questions where you have the, would they give you, if it's exo or endothermic, and then they give you the entropy and it tells you whether or not it's containing. How would it be worded?
I'll ask you, is this reaction spontaneous or non-spontaneous, and when? I'll give you numbers, and I can ask you at high temperatures, what is this, spontaneous or non-spontaneous? Or I can tell you, describe, if I have this and this, which one of the following is true? That'll be a little bit more complicated, yes? Okay, well, that's loaded. We have to know about oxidation numbers, okay? We're still gonna go, I haven't sent you the slides, yes?
Nope. I think you should just give up on it.
But you haven't needed them because you haven't asked me, right? Right? Or a practice test. Nobody has asked me. But anyway, we're gonna look at some of the stuff now on the slides, okay? And I'm gonna send it to you after class. Hopefully. So you have to know oxidation numbers, okay? If you do not know oxidation numbers for the last electrochemistry chapter, you're not gonna get any of the questions right on the test. So how important is it for you to know oxidation numbers? Of extreme importance. That's how important that is. I'm going to write from 6 to 8 questions on the final exam on electrochemistry and from 6 to 8 questions on the final exam on this chapter that we just covered. Okay? So you can kind of more or less imagine what they are. So as far as oxidation numbers, do you know them? No?
I know oxygen is -2.
Yeah.
Why not? Your 1045 instructor did not teach you well, huh? Your 1046 instructor is not going to teach you well either. So, okay, I'm going to give you very briefly the rules for this. If you don't have time to write it, that's too bad. Okay? So, these are oxidation numbers of the following. Oxidation number of all elements is equal to 0. So elements, oxidation number, 0. Is this an element? Nope. This is an element, because it's composed of only what? Oxygen. It doesn't matter if it's 10 of them or 5 of them. Oxygen, this is an element. How about this one? That's confusing. N2. What's the oxidation number? 0? Very good. I'm going to give you the hardest one of them all. Oxidation number of this, S8.
0.
Very good. You will not be able to get this one. Say 50.
0.
Okay, very good. Oxidation number of all monoatomic ions. This is the next rule. Monoatomic ions is equal to the ionic charge. That means, what's the oxidation number of sodium? It's still 0. Got you. I knew it. Oxidation number of that is 0 because it's an element, is it not? Now the next rule was the oxidation number of monoatomic ions. Sodium does form a +1 cation, so the oxidation number when it's plus is +1. Okay, but when it is plus, if it's not, it's not. What's the oxidation number of cobalt 2+?
+2.
+2. What's the oxidation number of F-? -1. Okay, so that's after that rule. Oxidation number of oxygen when it's bound to something else, because if it's oxygen by itself, O2 is 0, yes? But when it's bonded to something else, what? I don't know, I don't think so. So, the oxidation number of oxygen when it's bonded to something else, it's always -2. Unless it is a peroxide, in which case it's -1. I'll never give you a peroxide on the test. Peroxide looks like this. Okay? So every time you see oxygen, your guess would be it is -2. Oxidation number of hydrogen, but not hydrogen elemental form, right? Will always be +1. So hydrogen next to something else will always be +1, except when bonded to a metal, in which case it will be a -1. I'll try to stay away from this -1. So whenever you see hydrogen, it will be +1 in general or 0. Okay? In general, I'm not saying I'm not going to give you -1. The addition of the oxidation numbers is equal to the ionic charge of the ion, let's say. So when I add all the oxidation numbers, it has to add up to whatever charge this thing has. So NO3-, the addition of this oxidation number with these oxidation number must add up to -1. Okay? What else? Am I forgetting something? Halogens. Oxidation number of halogens in general is -1. Unless the halogen is bonded to something more electronegative than itself, in which case you'll get positive oxidation numbers. So, oxidation number of halogens usually what? -1. But usually -1 doesn't mean it's -1 all the time, right? So let's say this. What is the oxidation number here on oxygen?
-2.
It's -2. Okay, but on chlorine here, it's not -1. It is not -1 because it's bonded to a more electronegative element. It
Mm.
has to get a positive oxidation number,
It's +2.
which will be, what do I have to add to -2 to get -1? +1. How simple is that? There is no more rules, not that I remember. Turn this thing off.
This one?
Yeah.